Okay, in this video we will take a look at more network hardware, and specifically we'll take a look at how routers work. So remember from earlier lectures that routers operate at network layer, or the network layer, which is OSI layer 3. They work with packets and they are used to connect separate LANs or logical networks to form an internetwork. So you have at least two LANs connected by a router, and as a result you have those two LANs forming an internetwork. And the entire internet can be viewed as a whole bunch of LANs connected by routers. Remember also that broadcast frames in one LAN are not forwarded by the router to other router ports, that is, other networks. Routers are used to create complex internetworks with multiple paths for fault tolerance. That is, if one router fails or a switch fails, then the way routers are set up, you should be able to find another path from source to destination that avoids the fault. So you're tolerant to faults in routers. That was the idea. It's not always possible, but that's the intention of the way internets are set up, internetworks are set up. Okay, so look at some of the features of routers that we've seen before. So remember that each router can have at least two interfaces. So for example, this router H is connected to network 8 and network 7, and a whole bunch of these routers have two interfaces, but you'll see also cases where, for example, router E is connected to network 7, network 3, and network 4. So this is an example of a router with three interfaces. Each router has its own routing table, and this is a little bit more complicated than switching tables and switches. And so remember, the main thing that you want to remember is that when a router gets a frame, it opens up the frame, looks inside the packet, looks at the destination IP address, and then it may have to consult its routing table to figure out which interface will send out that packet out packaged in a frame. There are different routing protocols, and we'll take a look at the two main kinds of routing protocols that we will come across, we tend to come across. And then remember also that you can set up access control lists for networks to filter out packets. So you can have a router functioning essentially as a firewall, saying that I'm not going to accept IP addresses that are destined for some range of addresses if it's coming out of network 8, and the other way around as well. If there are IP addresses from certain source IP addresses, so if IP addresses are in a certain list of source IP addresses, I'm not going to let those packets into, let's say, network 8, for example. So you can set up all kinds of features. We're only going to really talk about mainly interfaces and tables, not so much the actual routing protocols. Okay, so routers must have at least two interfaces to be useful. You can have a router with just one functioning interface, but it just doesn't do anything. And so you have to have two. Usually that's most common is two interfaces, and that way you connect two LANs. When a router interface gets a frame, it opens it up, and but also looks at the destination MAC address to make sure that it is destined for that router. And assuming that it matches, the router looks at the packet inside the frame, and And if the IP address, the destination IP address matches the router's actual IP address, then it doesn't do any routing. It just consumes that packet. That is, it says, okay, this packet is destined for me, and so someone is trying to send me a message, and therefore I don't have to consult the routing table. If the destination IP address does not match the router's interface IP address, then the router will do the routing. That is, it will consult its routing table to figure out how to get the packet on its way to its destination. And so this process of moving a packet from the incoming interface to the outgoing interface is called packet forwarding. It's also called a hop. That is, that packet comes in one interface, hops over the router, and goes on to its next hop. Okay, so there's a lot going on in this one figure, and so you might want to take quite a few minutes actually to look at this one slide much more closely than all the others. This is probably the most important one, and I'll try to break it down into steps. So first of all, notice computer 1 is going to send a packet of information to computer 2. So this is the source, computer 1, with IP address 192.168.1.10. It wants to send a packet to computer 2, which is 192.168.2.21. So it's outside the first local area network. That's assuming that the subnet mask is 255.255.255.0. That is, only the last 8 bits are changing inside a LAN. Okay, so once again, computer 1 in LAN 1 wants to send a packet to computer 2 in LAN 2, and computer 2 is on a different subnet, different LAN, connected by a router. Okay, so when it has to do that, remember that the computer 1 will have a list of MAC addresses that are in its LAN. So when it sends out messages, it only sends out frames destined for its LAN. And so how can computer 1 send a frame that's destined for computer 2? It cannot do that directly. It has to send a frame destined for its, usually, gateway, one of the gateways. So if there's only one gateway, let's take the simple example where there's only one gateway, and so it will send a frame where the destination MAC address is the MAC address of the router interface that is facing LAN 1. So in this case, notice it's 000C85153115B. That's the destination MAC address of this frame that computer 1 is going to send, and it'll go out to the switch or whatever, and then it'll make its way to the router, because the router's Ethernet address is 000C85153115B, which is the destination MAC address. So the switch should send it to this router. And if the switch has to do a broadcast, that's fine, because the router will get it and it'll say, okay, this MAC address is my MAC address, and therefore I will take it and open it up and look inside that frame and see the packet. So the packet inside that frame has a destination IP address, which is computer 2's destination IP address, 192.168.2.21. And the router says, okay, this is not my IP address, and so I will have to consult my routing table to figure out where to send this out. It turns out there's only one other interface, so it's pretty much got to go there. But what it'll do is it'll consult its routing table, let's say, and says, okay, here is an entry for destinations that are in this network 192.168.2.0/24. Remember, this is CIDR notation, meaning that the 24 most significant octet bits represent the network. And so this is a match. 192.168.2.21 matches this rule 192.168.2.0, same subnet, and therefore that packet should go out interface ETH-B or Ethernet B. So what it's saying is that this frame that comes in from computer 1 through the switch to this interface, router 1 knows by looking at this routing table that it should go out Ethernet B. And then there's additional details, but to keep it simple, this is the basic information that you need to figure out where that packet will go. Okay, so let's just recap. Computer 1 wants to send a packet to computer 2 in another LAN, and so it uses the IP address of computer 1 as the source IP address and the IP address of computer 2 as the destination IP address. In the frame, computer 1's MAC address is the source MAC address, and the destination MAC address is that of the router, not the MAC address of computer 2, which computer 1, as far as networking, does not know what that MAC address is. Okay. The router receives this frame coming from computer 1 with the destination MAC address matching the destination and the MAC address of Ethernet A interface. And so what the router says, okay, this is coming to me. I'm going to open it up and look inside the packet, and then looks at the destination IP address, figures out it's not for the router, so it consults the routing table. It says, okay, I know where this goes. Just send it out Ethernet B. And so what the router will do is it will take that packet that was inside this first frame, put it inside a new frame, and send it out from Ethernet B onto its next destination. And we'll look at how what the next destination information is like in routing table. But in this case, what you will see later on is that if you send it out to this subnet 192.168.2.0, it is going to be listed as being directly connected to this interface. Okay, and then what it'll do is essentially just like with the LAN station ARP cache or ARP table, it will remember if it had ever heard from computer 2 and knows its MAC address, then it will know what the destination MAC address is. So on this side of router 1 Ethernet A side, it does not know MAC addresses of computers in this side, Ethernet B side, or the LAN B. On this side, you will have not only do you have the switching table, which is internal to the router, but you'll also have that it'll have a list of MAC addresses on this, only on this side, that is Ethernet B side of the network. And so it'll have something like an ARP cache. And so it'll know that any message going out to 192.168.2.21 should go to this MAC address 001D D8A4B941, which is the MAC address of computer 2. And if it doesn't know it, it can just send a broadcast anyway, and then or do an ARP request. Send out a broadcast ARP request and say who is 192.168.2.21, and computer 2 will respond saying it's me and here's my MAC address, and then that Ethernet B interface will save that MAC address in the ARP cache and will know what to do the next time. Okay, so after all of this, what happens is a frame sent by computer 1 reaches the router. Router 1 discards the frame but keeps the packet, puts that packet into a new frame, and sends it out with a new destination MAC address of a LAN station in the second LAN. The source MAC address will be that of the Ethernet B interface. So if you take a look at this, hopefully you can read this. It's the source MAC address is 000C85472A6F, which is the MAC address of the Ethernet B interface. The destination IP address is the IP address of the computer. That's directly from here. The source IP address is the source IP address of computer 1. So if you take a look at this, there's a lot going on in this one slide. This is one of the more important slides in this whole course, actually. And so it's a lot of very important details that I would ask that you pay special attention to. This one this one slide. Make sure it makes sense to you, and then definitely ask questions later. Okay, so I'll stop this video and we'll do the rest of the video on the remaining material.